So welcome to the next session on laws of probability. Here we learn about the addition theorem, the laws of probability, and also the use of De Morgan's laws. So if A and B are two sets, we have denoted it by a Venn diagram, then probability of A union B is probability of A plus probability of B minus probability of A intersection B. Because you add A, you add B, you add it twice. So you have to subtract the common part, since the common part is added twice. A and B are mutually exclusive if A intersection B is empty. So in that case, probability of A intersection B will be 0. And probability of A union B becomes equal to probability of A plus probability of B. Probability of A complement is 1 minus probability of A. A complement denotes the complement of A. And this is in 3 sets. If A, B, C are 3 sets, then probability of A union B union C is probability of A plus probability of B plus probability of C minus probability of A intersection B minus probability of B intersection C minus probability of A intersection C plus probability of A intersection B intersection C. And we have De Morgan's laws, which states that A union B complement is A complement intersection B complement. A intersection B complement is A complement union B complement. So coming to questions, E and F are two events such that probability of E is 1 by 4, probability of F is half, probability of E intersection F is 1 by 8. Find the first part probability of E or F and the second part probability of not E and not F. Now probability of E or F or denotes union. So it is probability of E union F, which is probability of E plus probability of F minus probability of E intersection F. Substituting the values given, you get 1 by 4 plus 1 by 2 minus 1 by 8, which is 5 by 8. Probability of not E and not F. Now what is AND? AND is intersection. So this is probability of E complement intersection F complement. And what do we use here? De Morgan's law. So this is probability of E union F complement, which is 1 minus probability of E union F. We have already calculated E union F probability as 5 by 8. So I get 1 minus 5 by 8, which is 3 by 8. Question 2. A and B are two candidates for a job. The probability that A is selected is 0.5. Probability that both are selected is at most 0.3. Can the probability of B being selected be 0.7? Now probability of A is 0.5. What is at most? At most is less than or equal to. So probability of A intersection B is less than or equal to 0.3. Multiplying by minus 1, I get minus probability of A intersection B greater than or equal to minus 0.3. And we have the formula of probability of A union B as probability of A plus probability of B minus probability of A intersection B. So we have probability of A union B is always less than or equal to 1. Why is that? Because the maximum probability is less than or equal to 1. And this will be greater than or equal to 0.2 plus probability of B. Because we are given that probability of A is 0.5. So 0.5 minus 0.3 is 0.2. So I have 0.2 plus probability of B less than or equal to 1. Or probability of B less than or equal to 0.8. And our question is it possible for the probability of B to be 0.7, which is true, because 0.7 is less than 0.8. Coming to question 3, the probability that a student will pass the final exam in both English and Hindi is 0.5 and the probability of passing neither is 0.1. If the probability of passing the English exam is 0.75, what is the probability of passing the Hindi exam? So let E be the event of passing the English exam and H be the event of passing the Hindi exam. So probability of E intersection H is 0.5. We are given that the probability of passing neither is 0.1. That is, we have probability of E complement intersection H complement is 0.1. And we are given probability of E as 0.75. Now what is E complement intersection H complement? E union H complement. So I have probability of E union H complement is 0.1, which means that probability of E union H is 0.9. So we use the law of probability. Probability of E union H is probability of E plus probability of H minus probability of E intersection H. Substitute for E union H, E and H, E and probability of E intersection H. So we get finally probability of H is 0.65, which is a probability of passing the Hindi exam. Question 4. Find the probability of getting an odd number on the first die or a total of 8 in a single throw of 2 die. So let A be the event of getting an odd number on the first die. So what is probability of A? When you throw a die twice or a pair of die, you get 36 outcomes. An odd number on the first die will be 18. So probability of A is 18 by 36. Let B be the event of getting a total of 8. So B will be 2, 6, 3, 5, 4, 4, 5, 3 and 6, 2, and A intersection B, odd number on the first die, and the total of 8 is 3, 5, 5, 3. So what is probability of B here? 5 by 36, and probability of A intersection B is 2 by 36. So probability of A union B using the law will be 18 by 36 plus 5 by 36 minus 2 by 36, which is 7 by 12. Coming to question 5, a bowl has 20 apples and 10 oranges, of which 5 apples and 3 oranges are defective. If a person takes out 2 fruits at random, find the probability that both are apples or both are good. So we have 20 apples, 15 are good, 5 are defective, 10 oranges, 7 are good, 3 are defective. So let A be the event that both are apples and B be the event that both are good. So what is the probability of A? There are 20 apples, so 20 C2, and totally how many fruits are there? 30. So 20 C2 by 30 C2. Probability of B, both are good. So we have 15 plus 7, 22 which are good. So probability of B is 22 C2 by 30 C2. And both are good apples will be just 15. So probability of A intersection B is 15 C2 by 30 C2. So what do we do here? Again substitute in the addition law. So we get the answer as 316 by 435. So we have discussed the addition theorem and its applications and the use of De Morgan's laws. Do try out the assignment and contact me for any further help. Thank you.